Welcome to Chapter 10, and Chapter 10 is the beginning of hypothesis testing. You'll notice, starting in this chapter, that there are more videos and the videos are longer, and that's because a lot of students really struggle with the concept of hypothesis testing, so I tried to break it down as best I could. So in this first video, we're going to take a look at an introduction to hypothesis testing, and then we're going to spend some time looking at each of the different parts in future videos. The biggest hurdle that I find in hypothesis testing in my students is that they really struggle with just understanding the concept. So they can do the calculations, they get to the end, they don't really know what they've done. So hopefully I can help clarify that a little bit. And again, you'll learn more and more as we go through, but hopefully this will give you sort of the basis. So up to this point, what we've been doing is we've been creating confidence intervals. And a confidence interval is an interval that is centered at either x bar or p hat, which is, of course, sample data. And then we do all of our magical calculations to find E, and we move E to the left and E to the right of our sample data, and we say, I'm whatever % confident that the true population mean or proportion falls in that interval. And so again, perhaps this is the true population mean or proportion. And so we're going to capture that whatever % of the time. So that's what we've been doing up to this point. So hopefully that makes sense to you, because hopefully you've done all of the confidence intervals and understood that what we're doing is trying to find what the true mean or proportion would be based on some sample data. Now what we're going to do now is switch gears a little bit. We're still going to have this value, but now what we're going to do is we're going to say if, and we don't know the true mean or proportion, so if this is mu or p, we're going to say how likely is it that I would find this sample mean or proportion. So for instance, let's say I expect to flip heads 50% of the time. And I'm flipping coins and flipping coins, and I find that I flip heads 52% of the time. Would you be surprised by that? Probably not. 52 is pretty close to 50. What if I were flipping and I flipped 72% heads? Well, that's probably not a great situation because we're expecting 50. So what the hypothesis test says is this mu or p, in this case p, of 0.5 is probably not true, because if it were true that I had a fair coin, that I was supposed to get heads 50% of the time, and I ended up getting heads 72% of the time, this is probably not correct. That's what a hypothesis test does. It says, if this is our true population mean or proportion, how likely is it that I would find our sample? And if it happens all of the time, if it's very common, then the null, or the, null, I don't want to start throwing words like that, the hypothesis that we started with was probably true. And if it happens very seldom, then the hypothesis that we started with was probably not true. As we're going through the rest of this video, what we're going to do is look at one hypothesis test. Now, I struggled with whether or not to show you an actual hypothesis test because you don't know all of the parts. So just know that we're going to talk about some things in this video that we're going to go into further detail in future videos. So if there's a calculation that I sort of skip over or something like that, it's probably because I'm going to cover it in detail in another video. So through the rest of this video, we're going to look at this question. Based on historical data, the Board of Education for one large school district believes that the percentage of high school sophomores considering dropping out of school is 10%. So typically, as I'm reading through a question like this, I will circle or highlight things that are important. So 10% is what we believe is going to happen. Now, the fact that we believe that's what's going to happen means this is our hypothesis. And the high school counselor in the district claims that the percentage is too high. So this is going to have to do with our hypothesis as well. And again, this will come together in a minute. He collects a random sample of 50 sophomores. 50 is just the number. And finds that 8.5% of them, 8.5%, and 8.5% is sample data, and it's a percentage, so I'm going to label that p hat, have considered dropping out of school. Perform a hypothesis test with alpha equals 0.02, and that's the level of significance, and that's something we'll talk about more in a little bit. So the first step is to state the hypotheses. So there are two hypotheses always. The null hypothesis is always the one that we start with, and the null hypothesis, which we use h sub 0 for null, because null means nothing, and that's why we use a 0, claims that nothing has changed. So I'm going to skip down to this is just a copy of what we read on the last slide. The 10% is what we believe is going to happen. So the null hypothesis claims that nothing has changed, and again, that's why I'm going to write my null hypothesis is that P, the true population proportion, is in fact 10%. Then there is an alternative hypothesis, and the alternative hypothesis has everything to do with the context of the question. There are three choices for the alternative. We say that it's greater than, or less than, or not equal to. Those are our three choices. These two are called one-tailed because it's going in one direction. This is called two-tailed. We'll get into more of that later. But these are our three choices. So as we go back to our question, it says the school counselor believes that the percentage is too high. So I want you to notice that if it's too high, that means the school counselor believes that the percentage is less than that. That's where this came from. So before we continue, I want to just talk about the parts of the hypotheses. Again, just so we're clear. H sub 0 and H sub A just signifies which is the null and which is the alternative, and we always write the null first. The next thing will be either P for a proportions question or mu for a means question. This guy should always be equal to. This guy should always be less than or greater than or not equal to. And these two values should always be the same, and it should always be based on the status quo, which means whatever has been, we think will continue to be. So now we have our hypotheses. Our second step is to collect the data. So of course we would go back to what we learned in chapter 1 about how to gather data. Obviously in this class we're not actually going to go out and gather data, but what we will do is then perform calculations on that data. So we will be using X bar or P hat, which again is sample data. And those are going to be the same values that we used for our point estimates when we did our intervals, but what we're going to do is convert them into a z-score or a t-score. So this is where I'm not going to go into all of the formulas because it's going to be different based on whether we are looking at a mean or proportion and whether or not we know the population standard deviation. So for this particular example, I will give you the z-score formula, which is p hat minus p divided by the square root of p and then 1 minus p or q, depending on how you like to look at it, divided by n. So that's what I've done here, is remember my hypotheses were that p is equal to 0.1 and that P is less than 0.1. And so 0.1 is P. That's where this guy came from. P hat was the observed percentage. So we observed 8.5%. That's where that guy came from. And then, of course, 0.1, 0.9, and then 50 from N. So now we have a z-score. Now, just to remind us, a z-score or a t-score kind of mean the same thing, except they're a different model, slightly different. T model is a little bit fatter in the tails. What I have found is that my observed value is 0.35 standard deviations to the left of the mean. That's all I have found so far. Now the third step is to analyze exactly what it is that we have found, and then of course write a conclusion. So the null hypothesis, again, states what the status quo is and what we assume to be true, and then what we're doing is now trying to find data that either support that null or say that it's not true. So again, as we talked about earlier, if our data disagree sufficiently, which sufficiently will be based on that level of significance, which is alpha, in our case 0.02 in this question, then we're going to reject the null. We're going to say the null was probably not true. So what I mean by that is, remember when I was talking about flipping heads, and if I expect to flip 50% heads, but I actually flipped 72% heads, it's probably not true that I can expect to get 50% heads. That's probably not a fair coin. So if I have sufficient data that disagrees with the null, we're going to say the null was probably not true. We have evidence to say that the alternative hypothesis is true. And then if we don't have enough data, then we're just going to fail to reject. So it's kind of like guilty and not guilty. We don't say guilty and innocent. We say fail to reject or reject. So as we come to the conclusion step, it's important to understand that there are two different ways to come to a conclusion, but that conclusion should be the same whichever method that we use. So I'm going to highlight both of these for you. The first is to use a rejection region. This is not typically what you will see if you're reading an article. So this is not the way that we're going to focus on in the course, but I do want to point it out to you because it does tend to make a little more sense to some students. And here's how it works. Think about our normal curve. What we're going to do is we're going to find a critical value. Now we should be really good at finding critical values because we've been doing that when creating confidence intervals. So it's the exact same thing. In this question that we're working on, we have a critical value, an alpha level, a level of significance, which is an alpha level of 0.02. So if I use Excel to find norm S inverse of 0.02, I get negative 2.054. Now here's what that means. This is good because it's a good visual. So obviously 0 is here. So negative 2.054 is pretty much right here. Now this is a left-tailed test. Left-tailed because remember the null hypothesis is that P was equal to 0.1 and the alternative hypothesis is that P was less than 0.1. So less than left-tailed, going to the left. So what that means is this is the rejection region. From the value that I found, going to the left is the rejection region. If I get a score of negative 2.054 or less, I should reject the null. If you'll recall, our z-score was negative 0.3536, so somewhere in here. So is that in the rejection region? No, so we should not reject the null hypothesis. We're going to fail to reject the null hypothesis. Now what does that mean? We're going to talk more about that in a little bit. For now, just know if it's in the value, if it's in the region, we reject. If it's not in the region, we fail to reject. Now, the test that we're working on is a left-tailed test. If our test were right-tailed, we would do the same thing, except we would use norm S inverse of 1 minus alpha, because we would need that value to the right. Or you could always do norm S inverse of alpha and then take the absolute value, because we would want the positive side. If we have a two-tailed test, we would have to take 1 minus alpha over 2. Again, all of this is stuff that we're going to talk about again and again as we look at left-tail test and right-tail test and two-tail test. So if this doesn't quite make sense to you yet, don't worry, it will as we move forward. So the second method is to determine a probability, and the probability is called a p-value. This is the way that we're going to focus on in this course because this is the way that most researchers draw conclusions, is using a p-value rather than a rejection region. And so here's what you need to remember about that. Again, it's based on alpha, our level of significance, and if we get a p-value that's less than alpha, we reject the null. Now let me just sort of bring it back to our coin question again. Remember I said, let's pretend that I should get 0.5 for how many heads I get, the percentage of heads I get, 50% heads. And I end up getting 72% heads. Well, if I do all of the work and find a p-value, that p-value is going to be super duper small. And if the p-value is super duper small, what that means is, hey, if this is true, this shouldn't happen. That's what a p-value says. If you have a very small p-value, it says, if this is true, then finding this would only happen whatever your p-value is % of the time. Okay, so if p is very small, less than our level of significance, we're going to say this probably wasn't true. And if p is larger than alpha, we're going to fail to reject. So looking back at the question that we just have been working on, we had a z-score of negative 0.3536, and I found the probability. And again, this is just using Excel. This is a norm S dist. And because it was a left-tailed test, I would just be norm S dist of our z-score, negative 0.3536. And I got 0.3618. So 0.3618 is p, and alpha is 0.02. Obviously, p is greater than alpha. We fail to reject. That's the same conclusion we came to before. And now the finale is to write our conclusion and tell what it means. So whatever method you use, rejection regions or p-value, you should have 3 parts. First part, I'm going to reject the null, or I'm going to fail to reject the null. Second part, why? Because of the rejection region, because of the p-value, whatever. Last but not least, for sure, is what does that mean? So let me show you both conclusions. The first conclusion is based on our rejection region, and so both conclusions will be the same except for this part, the data that led to the conclusion. So rejection region conclusion, since our z-score of negative 0.3536 falls above our rejection region of negative 2.054, we fail to reject the null. Okay, there is insufficient evidence that less than 10% of sophomores consider dropping out of school. So where did this come from? Well, let's remember. This was our null. This was our alternative. So if I fail to reject the null, then there's insufficient evidence that this is true. And that's where this came from. There's insufficient evidence that less than 10% of sophomores consider dropping out of school. Okay, let's look at the p-value conclusion. With a p-value of 0.3618, which is greater than our alpha of 0.02, we fail to reject the null hypothesis. Hey, exact same sentence. There's insufficient evidence that this guy is true. Hopefully that was a good preview for you. Again, if there are any parts that you're still fuzzy on, I will address those as we work through the next videos. Up next, we're going to take a look at writing hypotheses.